Game time. Here we go. 4-3. Slope. Let's have some fun doing some math. Hear that pen click? You know I mean business. Please title your notes 4-3. I want you to take a good, long look at this picture that you see here. Now, the person or people, the person that designed this house or the people that constructed this house, I want you to find as many areas in this photo as you can where people had to think about slope in the sense of construction. Feel free to pause the video as I'm going to go over it momentarily and take suggestions from the class. See how many things you can spot out in the video or in the picture. So I'm going to go here in just a minute. So pause the video, let people take a guess as what they think might require slope. Okay, here we go. I'm moving now. So pause. If you haven't paused, you better pause. I'm going. Here we go. Obvious choice. It's probably the pitch of this roof here. So we definitely have got slope going in right here. And I don't know what else other people said. Not everything else is obvious. That might be the only one that's like staring you straight in the face. There are going to be probably requirements as to how this pitch is attached to the ridge of the roof. You need to understand how to make these cuts and how to cut the angles where these boards are at the end here, and we can go into more detail on that later, as well as the angles where it matches up at the wall here. That's called the bird's mouth of the board, or the rafter. Okay, the next one, there are legal pitches for stairs. So slope is how things are slanted, right? This there's a legal pitch for stairs, how steep they can be as you're going in and out of a house. Definitely going to have some knowledge of how slope is entangled in the construction of these. Also, you have these kind of the shed roof we got going on over here. That's probably going to have something. Probably the less likely to be answered. If you got these, give yourself a pat on the back. Every house, if it's done properly, you have what's called positive slope on the house, which means all water that runs off your house needs to run away from your house. And so it's very carefully constructed that all the hills in every direction, no matter where you're going, are going to send water away or over into your neighbors or something, right? You want to get out away from your house so it doesn't get down into your foundation. If water gets into your foundation, it's going to crack and run through, so on and so forth. And I've got one more here. If you thought of something that wasn't on here, I'm going to be pretty impressed. I think I've got most of them. The other one is potentially in your gutters. Okay, gutters need to be slanted. Now, in the second house back here, there are gutters that are running away. When water runs off the roof, you want to have it at a certain pitch. You don't want it to all rush all at the same time and fill up one of the ends of the gutters. You don't want it too steep. I don't know if there are codes or restrictions on that necessarily, but slope definitely needed to be taken into account. But mathematically speaking, probably the stairs is important and the roof most definitely. If you got anything else, there's gutters right here too. If you got anything else, give yourselves a pat on the back. Let's do some actual slope calculations and go over what that is one more time before you guys revitalize your vision of slope. Okay, first things first. You need to know that any line that isn't vertical has a slope. So as long as it's not vertical. Slope is represented by the letter M. So what I want you to do in your notes is you don't have to draw these super accurately. Just draw a T. Oh boy, that's rough. Draw a T with some arrows going on there. Okay, and then you can draw these lines, maybe dotted. Draw the actual lines dotted. Whoops. Okay, going back. Any line that isn't vertical has slope. We use the letter M for slope. This line right here that's green has the slope, so we'd say M is equal to 0. It is a number. Slope can be quantified, how tilted something is. It's just a ratio, which is also what we've been learning about. It has no tilt. It is completely horizontal. Horizontal lines are said to have a slope of 0, which might raise some questions about this one. Now here it says any line that isn't vertical has a slope, which means this wouldn't have a slope. So this one's not 0 down here, m is what's called undefined. Undefined. So just write an example of what undefined slope looks like, something that's vertical. You could ride a bicycle on this. It just doesn't have any slope. You could not ride a bicycle on this very successfully. Okay. Slope is also, so right here, it's said to be the direction that it slants is said to be either positive or negative. And the way that I remember is if this is my x-axis, maybe been a while since you guys have done this, and this is my y, positive y-axis, positive x-axis. Down here you have your negative y-axis and your negative x-axis. As you go from left to right on your x-axis, as it's heading, if it's heading upward, think if you go from, if you're like reading a book, if you go from left to right, it's heading upward, think upward is positive. So in this case, this is an example of positive slope, and it could be any line, even if it's just barely shallow, but it's heading up, that's going to have positive slope. Down here, this one, as I go from left to right, the line is heading down, so this is said to have negative slope. M in this case, why did I write m equals 0? Goodness gracious, m is not equal to 0. Forget that happened. Please erase that. M is positive. M is greater than 0. Or m is positive. Okay, great. M is greater than 0. Down here, m is not equal to 0. M is less than 0. So down here, the slope, m, is less than 0. Or m is negative. So anytime you see something that as you go from left to right, if that's slanting downhill, then that means m is negative. Just like you read a book. Perfect. Next slide. Okay, so how do we quantify slope? If every slope has a number, that means as I tilt, if we're thinking about our house, this slope has a number. It has a numerical representation based on its relative to a horizontal and vertical axis. So right here, how sloped is this line? Well, basically, slope is defined as a rate of change, and it's written as a ratio. It's defined as the rise, so divided by the run, and so this triangle right here means change. So it's really just the change in the vertical direction, which is y, divided by the change in the horizontal direction, which is x. So when I went from this point to this point, what is the change in the vertical direction? Well, that is, ladies and gentlemen, this distance right here. I'm going to go one more. Cool. And how about the change in x? That's my run. How far did it go over in the x direction? Remember, x goes horizontally here. This is my change in the x direction. And so this point right here, I'm going to list this point. Remember, it always is x comma y. I'm going to list this point as, so x comes first. X comes first. This is, I'll call this point 1. This is x1, comma, y1. Okay, and yeah, good. So there is point number 1, x1, y1. And then over here, we'll just put the parentheses and comma in first. In blue, we're calling this x2, this is point 2, and y2. Of course, those are just subscripts that name our 2 points. So how tall is the change in y? How far did it go from here to here? Well, that depends on a lot of things. It's really just, if this is up at 10 and this is down at 5, then you do 10 minus 5, which is just y2 minus y1. So we were going to do that. This is y2 minus y1. That is what delta y is equal to. Delta y is equal to y2 minus y1. Okay, and then to get from here to here, you do the same thing. You're just taking the difference of the two x values to figure out how far apart they are. x2 minus x1. This is delta x. Delta means change. That's that Greek letter there. So you take the change in the y, the rise, divide by the change in the x, the run, and that's going to give you your slope. So up here, you've got your x2 minus x1 and your y2 minus y1. It doesn't actually matter. Which one is 0.1 and which one is 0.2. You'll still get the same answer either way. So let's do some hard calculations, and this will maybe make a little bit more sense. Okay, so you should have a sheet of graph paper handed out to you. You're going to use some of those sheets today, and some of them you're going to use later. What I want you to do is take that sheet of 8 graphs, and I want you to fold it in half, hot dog style, and rip those 4, and go ahead and put that into your notebook. The first example you're going to do is you're going to plot these 2 points, and we're going to find the slope. You're going to do that on your graph. So starting with one of those graphs, what I would do is in your notebook, come over in your notebook and over on the side somewhere, write example 1, and then over on your graph, so this is in your lined paper, right, in your notes, over on your graph, write example 1, so you know that these go together. Super. What is the slope of the line connecting these 2 points? So you could just write find the slope. So all you have to do is, just like we did before, we figure out the change in y, the rise. How far did you go in the vertical direction to get from this point to that point? That's pretty easy. So remember, your slope, m equals slope equals rise over run. Everyone needs to remember rise over run. Hopefully this is review. You should have all seen this before. It's just a good review to go over. Okay, the rise, what is my rise? What color did I use for rise? Red. So rise, how far did I go to get from this point to this point, whether it's up or down? Let's count. I'm going, I went from, looks like -1. This is -1 on the y-axis. I went -1 all the way down to -10. So my change is, I went, so I'm going from left to right, I went down 9, right? I went going this direction, I went down 9 to get from this point to that point. Okay, and in the blue, in the run direction, I went in the positive x direction, a total of, I went from -3, so 1, 2, 3, 4, 5, a total of 6. So I went down 9 over 6. So my slope calculation is equal to 9 divided by 6, -9 divided by 6, which is -3 over 2 in simplest form. That's how I want you to write your slope. So your slope is -3.2, or you could say it's -1.5. That's your slope. Both of these are correct answers. What this means is every time you go to the right 2, you're going to go down on your line. So if we take this here and we were to connect these points, now this is going to be a little harder. Oh man, this pad is tough to draw on. That was a terrible line. Yikes. Let's go ahead and use the line tool. How about that? We'll see what happens. If I were to connect these lines, ooh, that's much nicer. Remember, those lines do go on forever. Every time I go, there's my run. Every time I run 2, I'm going to go down 1, 2, 3. That point is also on my line. Every time I go over 2, I go down 3, also on my line. What this point says is, you can write this as a fraction as well, -1.5 over 1. That says is every time I go over 1, I go down 1.5, so on and so forth. That pattern is continuous because -3 halves is the same as -1.5. Super. So what's the slope? I did a very long-winded answer. We're going to be moving faster on the next questions. Basically, the rise and the run, this is what I actually expect it to look like. Okay. Oh, this one is slightly different. Let's go ahead and do another one where we're looking at the graph. Okay, find the slope of this line. This is what I would expect this to look like. Right off the bat, I'm going to say, this is how Slagle would actually do it. Okay, I'm going to say m equals the rise over the run, right? I would just pick 2 points that I know it goes through. It looks like this line goes through, so you can put this on an example, negative 4 comma 1, and it looks like it also goes through this point right here. Okay, so it looks like it goes through this point, which is negative 4 comma 1, and it looks like it goes through this point over here, which is 6, negative 2. So let's count the rise and the run. I went from negative 4 all the way up to 6, which means I have a run of 10, because it was 4 to go from here to 0, and 6 to go from 0 to 6. So a total run of 10. Let's try a little. Okay, great. What's my rise? Well, it looks like I'm right here. I need to go down. I'm up at 1. I go down to negative 2. My rise is 3, but I'm going in the downward direction. It's a positive x direction, so I'm going down 3. So negative 3/10 is my slope. That's it. Just count and you're done. Should be fairly easy for you. Okay, let's go back to the ones. What if you don't have a graph? What if instead I just give you points and I want you to do it algebraically? I want you to find that slope. Now this one you will not need to draw a graph. I will show you the graph in a minute, but let's do it on paper with that equation that I gave you. The equation was m equals rise over run, obviously, okay, which is equal to y2 minus y1 divided by x2 minus x1. And I just want you to have that, basically the differences in the y's minus the differences, and divided by the differences of the x's. You just got to make sure that you do it in the correct order. So label 1.1, this is 0.1, think about 1 as 0.2, we'll call this 0.2, and you just do the subtraction. That's how I always start. I draw my line, and then I put my two minus signs. The reason I do that is sometimes we have additional minus signs, remember? And so we're going to have to, I don't want to get tripped up. So I know that these have to be subtracting. I'm calling this 0.2, which means the y value of 0.2 is 0.2. That's the x value, the y value. Y value of 0.2 is 2. Now this says y1, which means I go to 0.1. The y value of 0.1 is 7. Fantastic. Down on the bottom, x2. That's from 0.2, the x value, which is 3. And from 0.1, the x value is negative 1. Boom. Okay, so now we got some simplifying to do. Good guys, bad guys, right? We got 2 minus 7. 7's bigger. That ends up being 2 minus 7. 7 bad guys. Bad guys win. There's negative 5 is the answer there. And then 3 minus negative 1. The opposite of a negative is always a positive, so this actually turns into 3 plus 1, which makes the answer 4. So our slope is negative 5/4. Now let's go ahead and grab this and click on our image. I've graphed those 2 points for us. Let's double check and make sure if our math held up. This says every time I go down 4, and we've got a lot of negative slope. Okay, every time I go down 4, I'm going to go in the positive x, down 5. 1, 2, 3, 4, 5. I'm going to go in the positive x direction 4. So there's my 4. There's my 5. Boom, boom. Rise over run. So that's the slope of our line in all its glory. Beautiful. Okay. Now that line goes on forever. Don't you forget it. I didn't put the arrows on the end. Next one. Okay. You guys go ahead and try this calculation on your own. If you get it, great. If not, you can watch the video. So pause, give it a shot. People know what they're doing. Fantastic. Double check in just a minute. I'm going to go pretty fast. Okay, I'm going for it. So if you didn't pause. Now's your chance. Bam. Kablamo. M equals y2 minus y1. M equals y2 minus y1 divided by x2 minus x1. Okay, let's name our points. Does not actually matter which one you choose. In fact, just for kicks and giggles, I'm going to call this point 2 and this one point 1. Doesn't matter. The slope between, so I do y2, go to my second point. y2 is actually 1. I'm going to draw my form here, which is a division sign with minus in top and bottom. I have 4 boxes I can fill in. I need my y2. My y2 in this case is 1. My y1 is from point 1, which is negative 6. Now on the bottom, x2. So I go to point 2, I grab the x value, which is 2, and then subtracting x1, which is negative 4. Whoa, lots of negatives here. 1 minus negative 6 minus a negative is really a positive, so that's 1 plus 6, which is 7. And then 2 minus negative 4. 2 minus negative 4 is really 2 plus 4, which is 6, which means every time when I reveal this graph, okay, every time you go up 7, there's my rise. Every time you go up 7, you're going to go over 6. So every single one we've seen so far was slanting downwards, right? We had a negative slope. That's because negative 5 divided by 4 is equal to, if you go to your calculator, that's equal to negative 5 over 4, right, which is negative 1.25. Yeah, it's equal to a negative number, which means every time I go down 1.25, I go over 1. Super. Now let's take a look here. Big reveal. The big reveal, folks. 7, 6. Every time I go up 7, or, okay, so every time I go up 7, I'm going to go over 6. Here we go. Look at that. Beauty. What a beauty. Yeah. Yeah. Oh, okay, here we go. Connecting my lines. And I'm going to move that a little bit so it's a little more accurate. Beauty. Yeah, and so I count over 1, well, count up 1, 2, 3, 4, 5, 6, 7, over 1, 2, 3, 4, 5, 6. There we have our line. 7/6 is the slope. Yeah. And honestly, this is exactly, if you look at a construction blueprint, they'll have a little key on the side that says, I think doing it by the graph is much easier because you don't have to do any of the stuff with minus signs. You can just count. So if you're good at using graphs, great, but I still want you to be able to do this as well. They're both useful skills. Okay, let's keep cruising. We did that. Okay, you guys try this one on your own. I don't care by what method you use. Pick a couple points you think they go through and see if you can guess the slope of this line. First of all, let's do it out loud right now. Is this positive or negative slope? As I am reading from left to right, it's going uphill, which tells me that it's positive. It fits the bill of those first couple graphs that we saw. So putting a point there, that looks pretty obvious, and a point there. You can go up 4, so it's 1 and 4, which means this is either 4 over 1 or 1 over 4, but remember it is rise over run, which is the vertical component over the horizontal component. It's a positive slope, positive 1 over 4. The rise is 1, the run is 4. Okay, so how does this all fit into what you're doing? Here I have a couple different truss types that might be used. Now trusses, not all roofs are truss roofs, but the way that they're constructed needs to be unbelievably specific. In fact, a lot of trusses are ordered elsewhere and shipped here, and they're engineered trusses to be perfect and know that they can hold lots of weight, right? The point I'm trying to make here, you don't need to draw all these trusses. I want you to know that roof rafters or trusses are usually calculated on a run of 12. In fact, most of the times, so this is just an example. It doesn't have to be necessarily these pitches, right? Doesn't necessarily have to be those. But what you'll see is on a document, if it's a blueprint or something, you'll see a little V like this. And it'll have 7, 12, which means you're on a 7, 12 pitch. Your rise is 7, your run is 12. And that is for both sides of the truss. That's slanting this way and this way. It doesn't really make a distinction between positive and negative necessarily. It just wants you to know these ratios are a 5/12 would look very similar, except it would be a little less steep, the connection between those two. A little less steep than the 7/12. Okay, so those are some trusses. Make sure you haven't, this is how it's written as a ratio like we've seen like the other time. The other time you might see this in construction is plumbing in a sewer line. It is required that your plumbing cannot be any shallower, the most gradual a plumbing pipe can be is 1/4 inch per foot. So every foot that you run, you can only go up or go down 1/4 inch. That's the minimum, which means you can make it steeper, okay, but you can't make it steeper than 3/12 unless you're going completely vertical. So it goes up to 3/12, and then you have to, and I'm not sure exactly why that is, but 3/12 is the steepest it can go, and then 2 vertical. Okay, and the reason you want to have that minimum slope is you don't want the solid waste to get stuck in the pipe. Like you don't want something to just sit in there and just last way too long, and then it's stuck. And then pretty soon you're calling me over to get it out, and that's not something I want to be dealing with, right? Perfect. Moving on. But this is going to be, gotta have that clicking if someone says, please, cut this pipe for me. I want it set up. I want it matched up. Basically, you're going to need to know exactly, you would have this pipe ready, this pipe right here. You'd put on the junction. You need to know exactly where that's going to need to be coming from this toilet. And that can get a little tricky based on the distance. Okay, there's some other verbiage for slope as well. And you may have heard me do this. So I'm actually going to go back to the very first slide. I had a couple hidden there, and I think I kind of skipped past them. If I look down here, these are all other words for slope that are commonly used in construction or the trades area. So slope is known as, so maybe pitch. You might see pitch, incline, decline. These are all possibilities. Pitch would definitely be for like roofs, incline, decline. Probably more like property. Grade, definitely roads. Percent is usually used in conjunction with the word grade. Slant is something I think you're all used to. Camber is like automotive. If you're talking about, if you look at a car's tires, they're not actually vertical. They kind of sit, if you're looking from the front, they kind of sit at this weird angle like this. And correct me if I'm wrong, boys, but I think that's like when you get in your car, it forces your tire to kind of settle out and flatten out to where it's supposed to be. And then your gradient. Gradient is just the long word for the word grade. So let's go back to that example. If you're dealing with roads, and this is just, I just pulled this offline, I don't know if this is specific for Alaska, but roads that are straight, you typically want a 1 to 3% grade. That means for every 1% is like 1 out of 100. So your rise, basically, you want water not to flow in the middle of the road because then it could freeze and turn to ice. You want to drain off the road. And so every 100 inches, right, every 100 inches that you run, you want to rise an inch, and that's just going to give you just a slight gradual slant. That's all you need to make sure that water is running off, especially when the rain's really coming down. So 1 inch, to 3 inches, maybe it's a little bit steeper. And you guys will notice if you lie flat in the middle of a road, that was probably not something I should tell students to do. But if you did, I know out in Two Rivers it's definitely possible. There aren't a whole lot of cars. You'd be able to see that slant, and you guys probably have seen this before, but it's real gradual heading down towards the edge. On a curved road, it might be a little bit different because you already have the slant, right? The road's already curved. And so if you're having an additional curve added on, it might end up changing how that road is appearing. You're going to want the water to shed even faster, especially because corners can get slick and whatnot. So, anywho, that's how it works. Here's your assignment, straight out of the book. Hope that made sense. Feel free to email with me if you have any questions. I'm assuming this isn't the first time you've seen this. We're going to go over, I'm going to have kind of some more applied problems involving slope upon my return. So thanks for watching. I hope you have a great day, and make sure to show all your work in your notebook. I do want you to draw these graphs in your notebook. Use a straight edge. What I would recommend, you don't have to draw the graphs necessarily. You do need to write the slopes, but I do want to see your work.
So I want to see the calculation like m equals y2 minus y1. Like I want to see what you're plugging in and how you're dealing with these negative signs in your final calculation. So good luck. We'll grade this as soon as we can when I get back. Thanks and have a great day.